So we spent the end of last week talking about linear inequalities, and we were graphing them. And if you remember, we had to take into account whether it was a solid line or a dotted line. Well, today we're going to talk about systems of linear inequalities, which is simply means that there's going to be two or more, but what we're going to be dealing with is just two linear inequalities that are graphed together. And when we were doing systems of equations, we learned three methods. We learned graphing, substitution, and elimination. Well, today we're going to talk about systems of linear inequalities, which just means that there's going to be two linear inequalities that are graphed together. And unfortunately, with linear inequalities, there is only one method, and that is graphing. So we're going to be revisiting the graphing method and how to graph, but it's the same thing we were doing at the end of last week. Instead of graphing one inequality, linear inequality, you're graphing two. The solution to a system of linear inequalities is the overlapping region of points that satisfies both inequalities or makes both inequalities true. The overlapping region, remember the shading? So we had to shade either above or below the line. Well, now we're going to be graphing two inequalities, and you're going to be shading both. And the solution to the system is going to be the area where the shadings overlap. So if I wanted to graph this one here, y is greater than negative x minus 1. Of course, I'm going to begin at negative 1. My slope is negative 1 over 1. So from here, I'm going to go down 1 and right 1. And I'm going to keep doing that until I fill up the graph, and I can go up 1 and left 1. We all know how to do this, or we should. And now I'm going to draw my line, but I have to take into account whether it's solid or dotted. And because there's no equal bar, it's going to be a dotted line or a dashed line. Okay. And now the shading. And because the symbol is greater than, I'm going to shade above it. So I'm going to shade the whole graph, everything above that line. Now I'm going to graph the second one. So as you can see, it's the same thing we've been doing, but instead of graphing one inequality, we're going to graph two. So for this one, I'm going to begin at negative 5. Negative 1, 2, 3, 4, 5. And my slope is positive 1 over 1. Remember, the number in front of x is 1, so 1 over 1. So I'm going to have this line here. And it's also going to be dotted because there's no equal bar. And then my shading for this one, because it's less than, will be below. So for the red line, I'm going to shade below it. So I'm going to shade everything in the graph below the red line. So the solution set is going to lie where the shadings overlap. In other words, right here. These are where my solutions are. Right there. S for solutions. In this little triangle right here. Not up here because there's no red, and not down here because there's no black, and over here there's nothing. But right here where there's red and black, that's where we're going to find the solutions. Okay? So let's look at another one. Let's do number 3. So for the first one, x minus 4y is less than or equal to 24. If you notice, it's not in slope-intercept form. So we have to put it in slope-intercept form. So we got to solve for y. So I'm going to take away the x. And when I take away x over here, I'm left with negative x plus 24. And now I'm going to divide by negative 4, and I'm going to divide everything by negative 4. So this leaves me with y. Now, remember, when you divide both sides by negative, that rule will always apply to an inequality. If you divide both sides by negative, you have to remember to switch the sign. Only because I divided by negative 4. Okay, so negative 1x over negative 4, that's a negative 1 over negative 4. A negative divided by a negative is a positive, so this ends up as 1 over 4x, which is okay. That's going to be my slope. 24 divided by negative 4 is negative 6. So now I'm ready to graph this one. I'm going to begin at negative 6. 1, 2, 3, 4, 5, 6. I'm going to go up 1 and over 4, up 1. I can go down 1 and left 4. And now I'm going to draw my line. And because I have an equal bar here, this line is going to be solid. The second equation, it is ready to graph. It's already in slope-intercept form. I'm going to begin at positive 1. And then from there, I'm going to go up 2 and over 1. Or I can go down 2 and left 1. And now I'm going to draw my line. And because there is an equal bar, I'm going to use a solid line again. And now I need to figure out where the shadings are going to fall. For the red line, I forgot to shade it. But it's greater than or equal to. So for the red line, it would be everything above the red line. Everything above this red line right here. For the black line, it would be everything below. So you see where they overlap at is right here in this big area right here. So right here would be all my solutions. So ordered pairs in this shaded area satisfy both of them or make both of the inequalities true. Let's look at one more. Number 4. X is less than negative 4. This is one of those special cases. Okay, remember when there's only one variable, the line that you draw will cross over that axis, which is the x-axis, at negative 4. Here's negative 4 on the x-axis, and a line that crosses over it will be vertical. But I have to take into account, is it going to be solid or dotted? Well, it's going to be dotted because there's no equal bar. And then I have to shade. Think about what it's saying. For this problem, for a vertical line, there is no above or below. There's only left or right. Well, if you look at this, it says x is less than negative 4. Well, numbers that are less than negative 4 are on this side. Right? Here's 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, numbers over here. So for this one, I would shade everything to the left because it's less than. Okay, for the red line, this equation, it's not solved for y. Take away 3x from both sides. These steps are almost always the same. You're left with 2y. I'm subtracting, so I don't need to switch the sign. I'm going to put the x term first, and then the y, and then the constant. I don't have y by itself still. I need to divide by 2. I divided by a positive, so I do not need to switch the sign. Negative 3 over 2x, that's my slope. And negative 2 divided by positive 2 is negative 1. So y is less than or equal to negative 3 halves x minus 1. I'm going to begin at negative 1. And from there, I'm going to rise negative 3 and run positive 2. And if I go up 3, back 2, I get this line here. And because this has an equal bar, it's going to be a solid line. And missed the dot there. The symbol is less than, so I need everything below the red line. So everything below the red line. So you can see where the solution is going to be right here, this almost a box, but not quite because it cuts off right there. So I'll darken in the solution set with a highlighter here. So that would be your solution set where the shadings overlap. And all the other problems are very similar. Let's look at a word problem. Sarah's pet store has never has more than a combined total of 16 cats and dogs. She also never has more than 9 cats. Write a system of inequalities and graph to show the possible number of cats. So she never has more than a combined total of 16 cats and dogs. So the cats plus the dogs is always less than or equal to 16. She never has more than that. She could have 16, but not more than that. So there's one of them. So we'll call this cats, and we'll call this axis dogs. So if I take away the dogs from each side, I get negative D plus 16. I'm going to begin at 16. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Actually, this needs to be cats. And this needs to be dogs because I'm calling this Y. So Y is less than, so Y is the up and down, so that needs to be cats. And that needs to be dogs. And then the other one, she also never has more than 9 cats. So the cats are always less than or equal to 9. So this means, actually, I'm not finished graphing that first one. I started at 16, and then I went down 1 and over 1, down 1 over 1, down 1 over 1. And this is going to be a solid line. And I'm going to shade below it because of the inequality sign. So we're going to be right here. That represents cats and dogs that she has. The number of cats is always less than 9. And since we're calling this Y, that means it's going to cross the Y-axis, or in this case, the cats, at 9. 2, 3, 4, 5, 6, 7, 8, 9. So it's always going to be less than 9. Well, less than 9 would be here. Which means that the number of cats and dogs combination is going to fall right in there. So there's your solution set. Systems of linear inequalities.